Okay, so this is going to be a relatively short video, as we are just introducing the idea of lines in a coordinate plane. And I went ahead and I just wrote out my notes for this particular lesson here. I'll let you pause the video and jot these down on your notes sheet if you need to. And these should all be concepts and skills that we should be somewhat familiar with as we dive deeper into this course. I will kind of point out that I always think it's funny when students realize that the slope formula is really just the point slope form, or maybe let me restate that. The point slope form of of a linear equation is really just a slope formula rewritten. All we're doing is just multiplying both sides by the denominator. And so whenever students see that, there is a moment here and there where some students' minds might explode. Um, but if you can read my chicken scratch here, hopefully you can make out most of my notes and have a chance to just review a lot of these concepts. But what I wanted to do is just really spend a few minutes just going over a couple of practice problems, some word problems involving linear equations. But I think the important thing for us to know about a linear equation, yes, it is an equation where the highest degree of the variable is equal to 1. So for example, y is equal to 2x. But the important thing about linear equations and often their applications is recognizing the rate of change. So when there is a linear rate of change, this is what we call the slope. And this is describing how much we are changing vertically with respect to some horizontal change, or that is to say, how much is our y changing with respect to our x. So it's a way of just describing that we're having the same rate of change. We're changing by the same y value for every change in x. So with that all being said, let's do a couple of problems with this. You may need a calculator for the first one just to make your life a little bit easier. So in this first problem here, we see that Nike's revenue sales were 12.25 billion in the year 2004, and the following year it rises up to 13.74 billion. Now, revenue sales are clearly not always linear, but if we were using a linear model to predict revenue sales in a given year, based on what we know, we first need to find the rate of change from year to year. So from 2004 to 2005, we can say the following. The rate of change here, or our slope, is, and we're going to write everything in billions. So this is 13.74 billion in the year 2005 compared to 12.25 billion in 2004. And what are we comparing this to from 2005 to 2004? Well, this is really just going to be 1.49, and again, this is 1.49 in billions, not in dollars, otherwise Nike would be in a lot of trouble. And so we can just use this as a linear model to describe what is happening from year to year. How much is the revenue going to be changing by? So let's come up with a linear equation to represent the revenue sales in any given year. So we're going to use the point slope form here. So we're going to say y minus y1 is equal to our rate of change, our slope, times x minus x1. We're just using our point slope form here. So let's use 2004 as our basis. So the values for 2000 from the year 2004. So we can say in 2004, Nike made 12.25 billion. Compare that to 2004. And our rate of change is 1.49. So based on this, we have a valid linear equation here. Now, if you wanted to write this in slope-intercept form, we can just simplify. And if you are interested in doing that, go ahead and try that. And if you want to compare, you should get 1.49x minus 297371. So we're going to use this model now to come up with the revenue prediction for 2006. So assuming we're going to have the same rate of change, we can say in 2006, y is equal to 1.49 times 2006 minus 2973.71, which comes out to 15.23 billion, assuming that they're going to grow by the same amount that they did in the previous year, or using the same amount of change every single year. Now, if you want to find the rate of change in, let's say, for example, 2014, which is a ways off, well, while you're watching it now, it's way back, we can say y is equal to, and take a moment, plug everything in, you should get $27.15 billion. Okay. All right, let's try the next one. In this next one, we're going to try finding parallel and perpendicular lines. And then, again, if you just go back up to your notes, remember that parallel lines are when the slopes are the same or the slopes are equal, and perpendicular lines occur when the slopes are opposite reciprocals of one another. So based on this information, so if we know that the point passes through 2, -1, and it's parallel to the line at this here, well, let's find the equation of any line that's perpendicular to either line. So looking at this, we're going to first take this equation and we're going to write it in slope-intercept form. And we're doing this because we want to be able to quickly identify the slope. And in that standard form, as you see it currently, we can't really do that. So we're just going to rewrite this in slope-intercept form, or what's y equals mx plus b. So y is equal to 2/3 x minus 5/3. And here is our slope. So now we're going to write the equation of this line that is perpendicular to that line. So we're going to say y, and just using point slope form again, if this is my x and this is my y minus the y1, which in this case is going to be y minus -1, is equal to 2/3 x minus, and the x value that we're given there, 2. And let's just clean this up into slope-intercept form. If we wanted to leave this in point slope form, this would be totally fine. And we want to write this in slope-intercept form, which is what this problem is asking. It's asking for point slope-intercept form. So we're just going to use some basic algebra here to clean this up. Minus 4/3. This was going to be +1, so we're going to subtract 1 here. So y is equal to 2/3 x minus 7/3. Here we go. Okay. All right, so there are some additional practice problems on the following page. I'm not going to do all of them, give you some opportunity to work through these. I think I've modeled a few of them, but let me just quickly do, say, the first for each of the next 2 sections. So in the first section, we're going to find the slope through these 2 given points, and then we're going to write the equation in the most convenient form. And then finally, we're going to find the x and y-intercepts. So let's break this down. So first, given this point here, you know what, actually, let me just jump to number 3, because I actually want to do a problem where I'm given 2 points and not the slope just directly being given to us. So if I want to find the slope here, I'm going to say, all right, my slope is, and I'm going to label this here if I want to, just so you can see what I'm plugging in. So -100 minus 7 over 1 minus 1. Well, this is going to be -107 over 0. And ask yourself, what's going on here? Well, this is undefined. So since the slope is undefined, what does that tell you about what that line looks like? Well, that means it is a vertical line. And how would that be described? Vertical line. Well, that's when x is equal to 1. That's what that vertical line would look like. So if I were to graph that at x is equal to 1, we have this vertical line here. Okay. So did want to do a problem where I found the slope, but let's try another one here. Let's try number 2. Okay. So for this one, we got some fractions, but still very much doable. Let's first find the slope. So we're going to go 4/5 minus 9 over -1 minus -3/2. And from here, let's clean this up a little bit. Let's see, this is going to be -41 over 5 times 2, which is -82 over 5. So there's my slope. Well, now that I know my slope, let's write my equation in the most comfortable form. So I'm going to use any one of these 2 points. I'm just going to use this one. So I'm going to say y minus 9 is equal to -82 over 5 times x plus 3/2. There's the equation of this line in point slope form. Okay, so there was my equation in point slope form. Here was my slope. And the last part is to now find the x and y-intercepts. Well, again, if you remember, the x-intercept is when y is equal to 0. So we're going to plug y equals 0 into the above equation, which gives me this. And if we continue to solve here, you should get x is equal to negative 39 over 4, in which case your x-intercept then is negative 39 over 4, comma, 0. Now, what about the y-intercept? Let me just do that in a different color. The y-intercept then is going to be when x is equal to 0. So when x is equal to 0. So plugging x equals 0 into this, I'll allow you to do that right now, but you should end up with 0, comma, negative 156 over 10 as your y-intercept. All right, let me do one more while I'm at it. Let's do one where we are writing the equation in slope-intercept form and then finding the x and y-intercepts. So let's just do, let's say, number 6 here. Let me zoom in on this. So again, we're going to find the equation in slope-intercept form and then find the x and y-intercepts. This should be pretty quick. So we're going to go ahead and write this as negative y is equal to negative 2x minus 3. Y is then equal to 2x plus 3. So that was pretty easy. So we see then our slope then is m is equal to 2. So our x-intercept, again, when y equals 0, and we can plug it into our original equation. That's just going to give us 2x is equal to negative 3. So x is equal to negative 3 halves. And again, make sure you write your x-intercept in, as a coordinate. So negative 3 halves, comma 0. And then our y-intercept is when y is equal to 0. So that's just 2x is equal to, x is equal to 0. I apologize. That's negative y is equal to negative 3. So y is equal to 3. All I did there was plug 0 in for x. And that means our coordinate here, or our y-intercept, is 0, 3. And there we go. All right. So take a moment, work through these problems. Since we're dealing with linear equations, you're really just concerned with slope and being able to write it in the correct form.